Hi folks, this is Bobby Hill. Now this is a long lesson, so I'm going to go kind of fast. You just have to pause a lot. According to one poll, 8% of the public says that they trust Congress. If a simple random sample of 10 people, what's the probability that at least one person trusts Congress? So the complement of at least one is none. So I'm going to do 1 minus the none. And since 8% don't trust them, or trust them, then 92% don't. So 10 times people, so we get choice D on that, okay? All right, so this is test of significance. It's a long lesson. Sorry. Laugh with me, you guys. I know you think it's funny because you love long lessons. And let's begin. Okay, so in exercise 10, I'm going to go to this next page right here. In exercise 10.5, we use the data, those three numbers right there, along with the standard deviation right there to construct a 99% confidence interval for the true population mu. And we got that interval right there. And we did this by using this formula right here. Well, I showed you the long way. Now I'm going to show you the short way in your graphing calculator. So get your calculators out. Pause this if you're not ready. Go get it out and clear your list. And when you come back, let's go ahead. We're going to enter those three numbers right here, these three numbers right here into list 1. All right, when you do that, then you press Stat, scroll over to Tests, and then scroll down to Z interval on mine. It's number 7. All right, and then you're going to plug in under the data, you're going to plug in your standard deviation, list 1, frequency 1, the confidence level, and then calculate, and you should get that interval right there. All right. Okay, so that one's a bad page right there. This page is better. Okay, given a sample set of numbers from a population, those numbers right there, there's 10 numbers in there. So clear your list again and plug those in. Okay, the next chapter we'll learn how to calculate the standard deviation, but for now it's always going to be given. Okay, so here it's it's equal to 1. So recall your sample standard deviation is that formula, and we get 0.316. So a significance test answers whether the sample mean reflects the population mean well enough. Okay, and you do this by what's called the null hypotheses, H sub 0, and the alternative hypotheses, H sub A. Okay, the null hypothesis says that there's no effect or no change, so it's always equal to whatever your population mu is. Okay, so if the null hypothesis is true, then the sample result is a good sample. It's just the sample at work. So, okay, so the alternative hypothesis says that there is change. So we're going to do some testing. So here we go. Example 10.9 on page 560. State the null and alternative hypotheses. So there's those 10 numbers right there. Diet colas are used for artificial sweetener, and what they do is they're testing to see if they lose sweetness, you guys. So they have 10 testers right here, and I'm just in a synopsis right here. I'm going to read this fast. Okay, and they tested the loss of sweetness. This 2.0 means it lost sweetness. This right here, this negative 0.4 means it gained sweetness. So what they did is they stored this cola at a higher temperature to simulate overlaps of time, and they had these 10 testers see if those colas lost sweetness. So remember, the positives means that they lost sweetness. It's kind of backwards, and the negatives means that they gained sweetness. Okay, so here they are right there. I just put that up there. So what's the null and alternative hypotheses? Your null hypothesis is always no change. So there's no change means that the change would be 0. And the alternative hypothesis is that there is change. In this case, they wanted to know, did it lose sweetness, which was a positive number. Okay, and that's all it's asking. Just state the null and alternative hypotheses. So part of your homework, just state the null and alternative hypotheses. It'll make sense in a second. So in the sample outcome, that should be a bar right there. This is sample mean, so x bar is 1.02. Is that surprisingly large enough under these conditions? If it is, then that's evidence against your null hypotheses and in favor of your alternative hypotheses. Okay, remember, sample standard deviation, well, in this case, was 0.316. And what if another 10 sample Kohler's tested had 0.3? Would that be significant enough? Okay, so to answer these questions, you need to find the p-values and the probability that these events would happen. So your p-values are from your z-scores, table A. What do you know? A result that would be small enough is statistically significant evidence against HO and in favor of HA. So it means the probability of such an event by chance would be very, very small. Unless otherwise stated, we always look for the p-values of 5% or 0.05, that would be statistically significant evidence against HO and in favor of your HA. Okay, also the probability is always to the right. We're always looking to the right. And the book always gives you to the left, so we always do the 1 minus the number. So are these numbers strong enough evidence against HO? Let's go ahead and calculate those. Remember, HO is equal to your mu that equals 0, and HA is your mu is greater than 0. It means it gains sweetness in this case, okay? So there's my Z formula. Going to plug the first one in, 0.3, okay? And then I'm going to plug in my mu is 0 right there, and my standard deviation from before is 0.316, and you get about 0.95. You look that up on your table A right there. And remember, we always want the right. So the table A always gives us to the left, so we subtract. So it tells us that 17% is 17% of the time we're going to get tasters that gives you a mean score of 0.3 of a sweetness loss. That's not good enough evidence right there. Okay, so let's try the other one. Oops, that's supposed to be a 1.02. Put a 1.02 right there. Okay, I'm pretty sure that's right, 3.23. So your z-score, when you get that, is 0.9994. So we do the 1 minus that, and you get 0.0006. Okay, well that's less than 5%. This says that 10 tasters would have an average score as large as 1.02, only 6 out of 10,000 times, because that's in the 10,000th spot. So 6 out of 10,000 times. Okay, that's strong enough evidence against HO and puts us in favor of HA. So since because it says that, 0.0006 of the time that's going to happen. So that's strong enough evidence. It's so small that it's strong enough evidence. So we can say HA is going to be true. It's going to be greater than 0 if that was the case. Okay. So get used to this type of wording. You're going to write it down for the next probably 2 chapters. Okay, so here's exercise 10.27 on page 564. All right, so student attitudes. The survey of student habits and attitudes is a psychological test that measures the attitude towards school and study habits of students. Scores range from 0 to 200. The mean score of U.S. college students is about 115, and standard deviation is about 30. A teacher, though, suspects that older students have a better attitude towards school, so she gives that test to 25 students who are older. Okay, so assume that the score and the population are the same, so the standard deviation is 30. So here we go, we're going to test to see if that works. So the teacher wants to test these hypotheses. The null hypothesis means there's no change. It's going to equal to the population mu right there. 115. Okay, she wants to know that they have a better attitude, so the bigger the number it is, the better the attitude is. So it's going to be greater than that. Okay, so what's the sample distribution and the mean score? The 25 older students if the null hypothesis is true. So sketch a density curve of this distribution. Okay, so here it is. Okay, so I'm going to go ahead, it's a normal distribution, and there's my standard deviation of the population divided by the square root of the number of people that they tested, and the square root of 25 is 5, and 5 goes into that 6 times. Alright, so here's my density curve right there. Okay, and all I did was I just made, there's my mean, the 115, and then since the standard deviation is 6, I just went plus 6, plus 6, plus 6, and then from the mean I went minus 6, minus 6, minus 6. So 3 standard deviations to the left, 3 standard deviations to the right. Alrighty. Okay, so suppose that the sample data gives another sample data gives 118.6. Mark this point and axes on your sketch. Boom, right there. Okay, in fact, the result was 125.7. Mark that point on your sketch. Boom. Okay, so using your sketch, explain in simple language why one result is good evidence and the other one might not be so good of evidence. Well, this one's farther away from the mean. This one's it's not even 1 standard deviation away from the mean. So that's reasonable right there. In fact, this is not even 2 standard deviations away from the mean. So that's reasonable also. But that's what I said right there. Assuming your null hypothesis is true, a value of 118 seems reasonable with that normal distribution, 115,6. Even the 125.7 seems reasonable, but that one's a little bit less likely than the one at 118, so it would be better evidence against your HO, but it's not even enough evidence because it has to be less than 5%. Okay, so shade the area under the curve. So there it is, shaded under the curve right there. Okay, we're always looking for the area to the right. Okay, one-sided alternative hypotheses testing is when it's either greater than 0 or less than 0. When your alternative HA is greater than or less than 0. Okay, and it's just like that shading one that we just did. That's a one-sided one right there. Okay, as opposed to a two-sided where it doesn't equal to. They just want to know, is it not equal to 0? So the graph would be this when it's two-sided like that. Alrighty, let's see. So studying job satisfaction. Let's see. I'm going to cut us off here. One of these here on one of these. Might be this one. Does job satisfaction assembly workers differ when they're machine-paced rather than self-paced? One study. I think I'm going to stop right here and just zoom ahead. Let's see. Yeah. Okay, this is a 2 study. I'm just gonna. You can kind of glance through that. We covered that. I'm short on time because it cut me off. I can only do a maximum amount of time. All right, there's your homework, you guys, and I'll see you guys next week.